I'm going to be working some problems from the condensing and expanding logs assignment. I'm going to start with number 22, and this one's going to have sound. Happy to do that. So, first one we got log base 4 of x to the 6th times y to the 4th. Because we're multiplying here, that means we can split them into two different logs where we're adding in between them. Okay. So that's just a property of logs, that if we have a product in there, we can split it up and add two logs of the same base together. Now here we have the power property, which means if we have a power in those logs, we can bring it out in front of that very log. So we got 6 times the log base 4 of x plus 4 times log base 4 of y. And that's our final answer. And number 23. This one's a fun one. Okay, again, we're multiplying inside that log, so I'm just going to go ahead and split it up into two logs right now. We have log base 5 of w plus log base 5 of the cube root of uv. Now, there's a couple things you can do with that cube root over there. One thing that we can do is we could split it up into two separate cube roots. Okay, so the cube root of uv is also, let's do this in a different color. This right here is also equal to the cube root of u times the cube root of v, which means we could write it like this: log base 5, cube root of u, plus log base 5, the cube root of v. So now we have to know something else about roots, which is that a root is another way of writing an exponent, a fractional exponent. So we've got, really here we have u to the 1/3 power, and inside this log we have v to the 1/3 power. So now you should see that we have these powers which can be written, we can bring those powers out in front of the log, which would give us a final answer of log base 5 of w plus 1/3 log base 5 of u plus 1/3 log base 5 of v. And you can leave your answer like that. And number 24, log base 4 a to the 5th b squared. We've got division going on here, which means we can split those up as two logs of the same base that are being subtracted. So just like with exponents, if we had a to the 5th over b squared, we would subtract those exponents, 5 minus 2. We're going to subtract the top and the bottom as logs. So division leads us to subtraction. And then again we have powers that we're going to bring out to the front of our logs. 5 log 4 of a minus 2 log base 4 of b. And here we are with number 25. We have 3 logs here, and one of them has multiplication going on in front of it. So if we have a constant being multiplied by a log, that means we can take that constant into the log, since we're condensing, and it will become a power. So we've got log 5 of x. Actually, let's go ahead and combine these two. They're adding, and they have the same base, which means we can multiply. We can put them in one log where x and y are being multiplied. Okay? Plus log base 5 of z to the 5th. Now again, we have two logs that have the same base that are being added together. So we can combine them into one log base 5 of x, y times z to the 5th. And notice that that z is the only thing that's taking that power 5. The other terms don't have that power on them. Okay, number 26 here, I just rewrote the problem in the red, and then you'll see in the black what I've done is I've taken these 3's that are in the denominator, and I've written them as the dividing by 3 is the same thing as multiplying by 1/3 here. And since I'm multiplying by a constant, I can bring that constant inside both of those logs, and so I have log 9 of c plus log base 9 of a to the third plus log base 9 of b to the third. Now all of that adding can be brought together into a single log of base 9, and in that log I'll have c times a to the third times b to the third. And then log base 9 of c times ab to the 1/3. Okay? And a lot of these are these little middle steps that you don't really have to write if you know what you're doing. I'm just trying to show why I'm going to put these together. Okay, so a and b are both being raised to the 1/3 power. And another way of writing the 1/3 power is as a root. Okay, so they're both under this same root. So it's log base 9 of c times the cube root of ab, which is the same as ab to the 1/3 power. And bring those together like so. Alright, and then the last one I'm going to do on this is number 27. After 26, number 27 is actually pretty easy because we've got these constants in front of our log base 4, so that'll be u to the 9th plus log base 4 of v to the 3rd. And once you've got those constants inside the logs, we can go ahead and combine them into a single log, where because we're adding, that means that inside the log they will be multiplied. Log base 4 of u to the 9th times v to the 3rd. And we will call that good.